recording, I'm going to talk about Ken Thompson. And specifically, we're going to talk about his Turning Award lecture titled Reflections on Trusting Trust. I'm going to use this document camera over here to display this document and break it down into non-technical language as best I can, so that if you don't have a degree in computer science or you're not working in this field, you can appreciate this document in all its glory / speech. Okay, so I'm going to minimize my reflections on trusting trust. Pop that over there. To what extent should one trust a statement that a program is free of Trojan horses? Perhaps it is more important to trust the people who wrote the software. So in this case, a Trojan horse would be the equivalent of a backdoor, meaning if you're logging into a computer system or a program with a username and password, there is a backdoor in there with a different username or password that a bad guy or person could use to access that system. And that backdoor in this paper is at the software level, meaning the computer software, not the hardware. So let's get into this a little bit more. I'm just going to adjust my document camera over here. So we have his introduction. And this was published, let's go down here, August of 1984. So quite a long time ago, almost 40 years ago now. So in our introduction, he starts off by thanking the organization for his award, and he's very selfless. He gives credit to all the people who contributed to this Unix language, which was a language that is the precursor to a language called Linux, which is a language for operating systems that if you use a computer made by a company called Apple, chances are a lot of those frameworks that are made in the Apple computers today on their software, their operating system software, come from this Unix design. Okay. So after that, he talks about his colleague, Dennis, and he talks about how he had such a close working relationship with this guy in terms of writing operating system software, that at one time they wrote 20 lines of code together, and this is an assembly language program. They did this not knowing they were each writing the same 20 lines, and they were the exact same thing. So that's how he identified that bond with this person. He goes on to tell this story about a program that he calls, he describes as cute. Okay, so in the first, and he does this in a 3-act structure, or stage structure. So stage 1, he talks about how when he was in college, one of the things he would do with his programming colleagues was to write the shortest self-replicating program, so it's almost like a loop program, possible. And so the idea is if you write this program, it'll just run forever. It will replicate itself throughout whatever system it's running on. So that's part 1. And he gives an example of this program. And there's a lot of notes in this code. And I'm not going to go into detail on this because this is not made for a technical audience. So if you know C, that's great. And if you don't, that's okay too. So the idea is this first part of the program creates the backdoor. So when you compile the software, you have a backdoor into the system. So then in stage 2, or act 2, we have what we call a chicken and an egg problem, which we can all appreciate that comparison, where we go on to talk about once the program knows it exists, it can recompile itself over and over again. So he goes on to talk about how you can train the program to maintain this backdoor in a replication format. So on our last page, Ken Thompson talks about this process. And he writes, if this were not deliberate, it would be called a compiler bug. So, but since it is deliberate, it should be called a Trojan horse. So Trojan horse is the word we're using for a computer virus that is a backdoor. So it gives a bad guy or person access to the system. And he talks about here how the bug would match the login command on a Unix system. And at this time, in the 80s, he worked at Bell Labs, and he worked at Bell Labs in the 70s too. So the replacement code miscompiles the login command, so it would accept either the intended encrypted password or a particularly known password. That known password's the backdoor. The encrypted password's the secret one that the common user uses. The result is that he could log into the system as any user. He talks about how this blatant code cannot go undetected because of the way the program works. The compiler would raise suspicion. So the final step is to add a second Trojan horse to cover your tracks. And the second stage is aimed at the C compiler. So he writes, we install this binary as the official C. We can now remove the bugs from the source of the compiler, and the new binary will reinsert the bugs whenever it is compiled. Of course, the login command will remain bugged with no trace in source anywhere. And here's his example in code. So he's got a couple if statements there. Then he goes on to talk about the moral. And in this case, I'll move the mouse off the screen. You can't trust the code you did not create yourself, especially if the code is from companies that employ people like me. So at the time this was written, Ken worked at Bell Labs. Ken's almost in his 80s now, and he's at a company you may have heard of in Silicon Valley called Alphabet. He goes on to talk about how this is a morality issue. And the argument he makes is that because backdoors can always exist in any software, it's about creating a society where we train people to make good choices when it comes to computers. And the comparison he makes is if you break into someone's computer, that's like breaking into their house. In his acknowledgement section, He says, I first read of the possibility of such a Trojan horse in an Air Force critique of the security of an early implementation of Multics. I don't know how to say that word. And if we look down at the reference number 4, we can see he listed it as unknown Air Force document. Well, thanks to the power of Google, and I'm actually not going to put the links in the description below. You can have fun searching these up yourself. I have that document. It's right here. So let's look at that under the document camera. So we can see Multics Security Evaluation Vulnerability Analysis. It's written by Paul A. Karger and Roger R. Schell, Maja, USAF. And this has a publication date. You can see down here, this article is a reprint of a technical report published in June 1974. So Ken got this idea from a paper he read 10 years before he got his reward and gave his speech. So that just shows that if you know anything about Easter eggs or how people design software before they talk about it, this is something that Ken had marinated on for a long time. So he read this paper, got the inspiration, did a bunch of work developing the Unix operating system, and then the legend is, did he actually add backdoors into the system, like he wrote about in his talk? We'll get into that in a second. First, let's just read this abstract. I'm not going to go too much into this document, but I want to just give it a quick look so that we can appreciate the inspiration Ken got from it. So this abstract is talking about a system, a security system that's evaluated to potentially be used for housing secret level documents and top secret level documents. So 2 levels of secrecy within the U.S. government. And they say that this software they were trying out to use for that wouldn't actually be secure. However, they end by saying that it can be used for keeping documents secure because it's more secure than the other software that's not secure, which I think Ken would disagree with. Okay, let's end by going back to this idea of whether or not Ken ever actually wrote software with backdoors in it on the Unix system. So this is a document from an old network message board called Usenet that existed in the 1980s. So in this board, these people are talking about how this question, whether or not he ever laid the Trojan horse in software or just talked about it. So we have this guy at MIT named Bill. I can't pronounce his last name, so I'm not going to try. And he writes, I actually think it was distributed. Ken talked about it at the second Unix users group meeting at Columbia, which is right next to Bell Labs. In my faded recollection, I believe he said there was code in the CCP that inserted code when compiled at login.c. So he's talking about where this went. Added code to recognize particular username and password independent of ECT password. ECT password on a Unix system is the directory where the encrypted password for the standard users are held. And then it reinserts the Trojan horse when recompiling this file format. So then he asked Ken himself the real story. And this came from Sunday, April 23rd, 1995 at 2 o'clock p.m., almost 3 p.m. And I'm not going to go into that part there. So this is from Ken. His email address. Thanks for the info. I had not seen that news group. After you posted it out, I looked up the discussion. Writing to the news just causes more misunderstanding in the future. There is no way to win. Note, I asked him if he minded my posting the reply. He said he had no objection. Then he goes on to say, FYI, the self-reproducing CPP was installed on ARM machines, and we enticed the Unix support group precursor to USL to pick it up from us by advertising some non-backward compatibility feature. That meant they had to get the binary and source, since the sources would not compile on their binaries. So this right here, in non-technical language, is Ken saying that they did install it on the Unix system. So that's from the guy himself. He did it. He built the backdoor. So and he wrote that he did it 11 years because it was written in 1995. He gave the speech in 1984. So 11 years after the speech where he got his award, and probably close to 20 years after he actually wrote the software. He ends by saying the compiler was never released. So in this case, he's saying that I only did it in a lab environment on the inside of the organization, and it never went to production in the wild. So I find this stuff absolutely fascinating because it really does give such a good history of computer attacks. And if you're gonna understand the history of operational security, you need to know this stuff. And even if you don't work in the operational security environment, I think this is just really, really interesting history in computing and operating system writing in general. In any case, that's all I got for you today. Please subscribe to my channel, even if this is the only video you ever watch, and leave a comment down below with what you think about this video and this information, specifically about how it influenced future hacking attacks. Thanks for watching.